Do a little math. A little math never hurt anybody. Number 90. We are asked to show this. Remember these are not necessarily these are not practical. They may have applications that I'm not aware of in engineering um, or something, some kind of science. But um, these are just mental exercises to see if you can play around with the symbolism and achieve the goal that they ask you to find. And if you look at it, it just looks a little weird. And first you've got f and it's got sine of x inside. We're used to having f of x instead of f of sine of x. And then if you look at the two integrals, one's got an x in front and one's got a pi over 2 in front. And somehow having an x in front of that makes it a pi over 2 instead. And to think about what this is right here, just think of maybe like f of x equals x squared, and then we're going to put sine x in there. So f of sine x is sine squared x, something like that. Okay, so you have some function, and then you're putting sine x in instead of the x, or in place of the x. It's a function within a function. Okay, anyway, so you look at it, you say, well, what am I supposed to do here? I have no idea how to even start. And all the other ones, we've made some substitutions. And so where do we start? They make a suggestion, maybe not just a suggestion, but a hint, or pull it up here. So yeah, it says use the substitution u equals pi minus x. If they didn't tell you to do that, then you might not even be able to get started here. So let's do what they say and see if we can just follow our nose here. I'm going to make the substitution u equals pi minus x like they suggest, and then that's going to prompt me to take the derivative implicitly on each side. That gives me du equals negative dx. Remember, the derivative of the pi is 0. Okay, and then I want to try to substitute for everything I see here, and what I see is a bunch of x's, so I better say, from here I can say that x is equal to pi minus u. If I solve for x on, move the x over to that side and move the u over to the right side. So now I can start to substitute. I also need to know what happens to u when x is equal to these bounds. So when x is equal to 0, then that means that u is equal to pi. And when x is equal to pi, that means that u is equal to 0. Okay, so when I do the conversion of that integral into a u integral, I'm going to get the integral, instead of from 0 to pi for x, I'm going to get from pi to 0 for u. For the x part here, I'm going to get pi minus u. Then I'm going to have f of sine of pi minus u. And it doesn't seem like we're going in a good direction here. I mean, it seems like we're making it worse, not better, but let's just keep following our nose because that was the substitution they suggested. Okay, and then I still have to substitute for the dx. That's going to be negative du. I'll put the du here, and I'll put the minus over on that side. Okay, so that's what we got here. We started with this thing. We made the substitution they suggested, and now we have this new gizmo. Now, one thing to note is that sine of pi minus u is equal to, that looks like pi minus n. Okay, so we have sine of pi, that's actually equal to sine of u. So now you can kind of see why they made that substitution. And so that's just one of those identities. Um, if you just take a simple example, if I do sine of pi over 3, that's this distance, which is 1/2. And then if I do pi minus that, that's going to be 2 pi over 3. That's more like a pi over 6 that I drew here. So let's do pi over 6 instead. So if I do pi minus pi over 6, that would be 5 pi over 6. That's the pi minus pi over 6. Okay, and then that, you see how the sign of that is the same, it's 1/2. So it's just an example to show you that that identity is true. And we're dealing with only, in this problem here, they actually say that we're only dealing from 0 to pi in the problem. Okay, and that's because, the bounds are that way. If you look, here's 0 to pi. Okay, let's go back and clean up what I was just doing here. So all that explanation here was just to turn this sine of pi minus u into a sine of u. So let's just write that down. This is equal to minus, it's pi to 0, and then I have pi minus u, and then I have f of sine u du. Okay, and then the next step here, let's switch the bounds using this minus here. So I'm going to turn that into 0 to pi minus u, f of sine u du. So that's where we're at so far. Now this can be broken into two integrals. If you look at where we're going here with this, you see, we want to end up with this right here, just a simple integral. So I'm going to break this up into two here. I have pi 0 to pi f sine u du minus integral 0 to pi of u f sine u du. I pull the pi out in front because it's a constant, and I don't pull the u out in front because that is not a constant. That's the variable that's part of the integral here. Okay, now this guy right here is the same as the original integral we started with. So you see we got a little bit of that back. So let's do, and remember, we can we can say we started off with this guy right here, and that's equal to the same thing with u's in it. So here's what I'm going to do. I'm going to rewrite this. It's going to take a second here, but this is, so what we've arrived at is that 0 to pi u f of sine u du, that was the original thing we started with. That's equal to this stuff right here. It's equal to pi 0 to pi f of sine u du minus 0 to pi u f of sine u du. Okay, and actually, you know what I want to do? I want to make this one x over here. Okay, so I'm going to make this equal to x. It doesn't matter. But that is truly what we started with. So that's what I'm going to do. Let's just do it that way. Let's make all those x's instead, because it doesn't matter. But that is what we started with. So let's do it that way. So we started with that, and this is what we found when we made our substitution. And then this one can be thought of as x too. Thinking x and bring to the other side. So that's really equal to x. And if I bring it to the other side, what I'll have is 2 of those 0 to pi x f sine x dx. And that's equal to what I have left here, pi 0 to pi f sine u du just a little cleaner version. So you see, this is what I ended up with. I have 2 of these is equal to this. So if I bring the 2 over, I have 0 to pi x f sine x dx is equal to pi over 2, dividing both sides by 2, 0 to pi f sine u du, but then I can just think of this stuff as x. So that's pi over 2, 0 to pi f sine u, sorry, dx. I want to make that x. Okay, and we've done what we were asked to show. Okay, so now if you want to get something of value from this, I mean, you're watching the video, maybe you have it for homework, maybe you're trying to learn this on your own. I mean, if you really want to do this yourself, what you ought to do right now is just take the problem and turn off, pause the video and just take a clean piece of paper and see if you can reproduce it. And it's really just a mental exercise. Can you concentrate long enough to keep track of everything? Can you keep track of all the tick marks, the minuses, and the little pi minus u's? Do you understand this step right here where you're switching? Then you go back and say, well, how would I think of this to do this by myself if they didn't give me that hint? And that would be tough, but the reason they would come up with this pi minus x is because sine of pi minus x is equal to sine of x. So that gives you something to do, gives you something to substitute, and then that's probably how they ended up coming up with this in the first place. Okay, let's move on from this. So that's number 90. Let's do number 91. Now we're going to use exercise 90 to evaluate we're going to evaluate 0 to pi x sine x 1 plus cosine squared x dx. Okay, well, supposedly, I'm supposed to use that previous one, and let's just say this one here is the x f of sine x dx from 0 to pi. Let's say that one, this here, so that would mean that this portion here is the f of sine x. All right, well, supposedly that, according to our exercise 90, right, if I go back up here, exercise 90 tells me that if I have x sine f of sine x, then that's pi over 2. I can remove the x in front, and I just have a pi over 2 in front instead. So this must be equal to pi over 2 f sine x dx. Okay, well, if I said that this portion here was the f sine x, so now this integral here will be pi over 2, 0 to pi, and then I just have sine x over 1 plus cosine squared x dx. Okay, so now we have an integral to compute, and when I see that 1 plus something squared, even though it's a cosine squared, it's 1 plus something squared, I'm thinking kind of like 1 plus u squared, 1 over 1 plus u squared, and that would be an inverse tangent. So let's see if we can make that substitution here. We're going to do u equals cosine x, then du is minus sine x dx. When x is equal to 0, u is equal to cosine of 0, and cosine of 0 is 1. When u is equal to, when x is equal to pi, then u is equal to cosine of pi, which is negative 1. Okay, put that up here. So when u is 0, then cosine of 0 is 1. And when u is pi, cosine of 0 is negative 1. Those are those locations there. There's 0, and there's pi. And the x coordinate. Okay, so I have everything I need. Let's put this integral into u form. I have pi over 2. The bounds are now from -1 to 1. And this portion right here is negative du. If I look down here, right, negative du is sine x dx. And then 1 plus cosine squared x, that'll be 1 over 1 plus u squared. I have du on top, and I have a minus, okay, because this portion here is minus du. Okay, I'm ready to go. This is equal to negative pi over 2. Then I have the integral. This is going to be inverse tangent of u evaluated from -1 to 1. Okay, so what is inverse tangent of 1? That is the place where tangent is equal to 1. It's the location. When you do inverse tangent, you get out the angle. So the angle where tangent is 1, tangent is sine over cosine. So if it's going to be 1, it's where sine and cosine are equal. Sine and cosine are equal at pi over 4. So tangent inverse of 1 is pi over 4. Okay, so let's continue this. This is negative pi over 2. When I evaluate, I'm going to do tangent inverse of 1 minus tangent inverse of -1. We just found out that tangent inverse of 1 was pi over 4. And now tangent inverse of -1. Tangent inverse is only defined over in this portion from negative pi over 2 to pi over 2. Okay, so when we're doing what is the angle where tangent is -1, we need to use negative pi over 4. We can't use 7 pi over 4 for this point here. We have to use the negative pi over 4 because that is the domain of inverse tangent. Or the domain, yeah. Anyway, so the value of inverse tangent of -1 is negative pi over 4. Now I'm ready to go. I have negative pi over 2. I have to switch these. This is -1 and +1. You guys probably saw that and were watching the whole video and you're like, oh my god, this guy, he's not going to get it. Well, I'm not going to redo my whole video. This is live, so I'm just going to redo this like this. That's negative, and then this one here. Let's fix it. I'll just go back and say what I just did. Okay, so I switched the bounds. I did 1 and then -1. So now I'm going to do -1 first. That gives me negative pi over 4. And then I do 1, and that gives me positive. So what I have here now is I have negative pi over 4 minus pi over 4. That gives me negative pi over 2. And then my final answer is pi squared over 4. I knew I made a mistake because it was coming out negative, so I realized I switched them. So if I were doing it another, I could have taken this negative at the beginning here and switched the bounds. That's kind of what I did in my head when I switched them. But anyway, I fixed it. So here we go. That's the answer. Pi squared over 4. All right, let's keep going. I'm on a roll here. That was number 91. Let's do number 92. Last problem in the section. Yeah, this has 2 parts. And here, for this last one, they don't give you any hint, but if you did the previous ones, then maybe you have some of it in your mind of what you might do here. So f of cosine x dx. If you're a normal person, when you look at this, you just pretty much have no idea what to do. And it's only after you've had some experience or you spend some time thinking about it that, I mean, it's hard for me to imagine not having any experience and then doing this problem. As I have a lot of experience, and so I can do the problem, but I don't know, you have to get the experience. Now, one thing I will say is in these previous problems, we've been doing a lot of these substitutions. And in this one in particular, we had a little identity that we used that was suggested to us right here, this sine of u, pi minus u, and sine u. So here we have to magically change from f of cosine to f of sine. And so you're going to have to come up with an identity so that you can get them involved. Because if you start with one, then you got to have, somehow magically transform it into a sine. So here's the identity that we're going to use, is that cosine of x is equal to sine of pi minus x, pi over 2 minus x. And let's just do a simple example here. If I have, say, pi over 6, if I do pi over 2 minus pi over 6, pi over 2 minus pi over 6, that's going to be 3 pi over 6 minus pi over 6, which is 2 pi over 6, which is pi over 3, okay? And you see how at pi over 6, the cosine, this little distance right here, which is root 3 over 2, is the same as the sine is for pi over 2 minus that. See, so sine of pi over 2 minus pi over 6, which is sine of pi over 3, is equal to cosine of pi over 6. Okay, that's just an example to illustrate this identity. So we're going to use this identity and start with this integral here. So we start with 0 to pi over 2 f of cosine x dx. That's what we start with on the left side. And then I'm going to say, well, that's the same. If I double click on cosine x, I could call it sine f of f of sine of pi over 2 minus x dx. This is Robert and this is Bob. Same guy, different name. Okay, well, now that I have it here, now I can kind of do what I've been doing in the other problems, and I just make the substitution and just hope that it turns out the way they say it's going to turn out. So we'll just follow our nose after we make the substitution. U equals pi over 2 minus x. Then du is equal to minus dx. And when x equals 0, u is equal to pi over 2. When x equals pi over 2, u is equal to 0. So this integral converts into the integral, now it's u, so it's pi over 2 to 0. We have f of sine u, because u is equal to pi over 2 minus x. The dx part, that's equal to minus du, so I'm going to put a du here and a minus there. And then I can switch the bounds by using that minus. So that's the same as 0 to pi over 2 of f of sine u du. And that's equal to, if I just change the variables, f of sine x, which is what we wanted to show. Okay, so we wanted to start off with this, and we wanted to end up with that, and that's exactly what happened. And in order to do that, we used this substitution here. This is Robert, this is Bob. Okay, now there's a part B to this. Part B part B says to evaluate 0 to pi over 2 of cosine squared x dx and 0 to pi over 2 sine squared x dx. Okay, so what we're going to do is we'll say f of x is equal to x squared. So f of cosine x equals cosine squared x, and f of sine x is equal to sine squared x. Okay, so according to part A, so this is part B here, by part A, we have the integral of 0 to pi over 2 of uh, f of cosine x dx equals 0 to pi over 2 of f of sine x dx. Okay, so from that, what we can say, because these things are equal, we can say that the integral from 0 to pi over 2 of okay, so these two things are equal, right? So let's do it this way. So if I have cosine squared x dx, this guy here, okay, is equal. Let's write it. I'm going to write it out instead of just saying it. I was going to say it. I'm going to write it. Okay, so these two things are equal. Okay, and that's what we want to compute, but they're equal, right? So if I have two of the cosine ones, just you could do it with the sines too, but if I have two of the cosine ones, that's the same as 0 to pi over 2 cosine squared x plus sine squared x, because they're the same, so I have two of the cosines, but the cosine's the same as the sine, so that's the same as cosine squared plus sine squared x, because this is like cosine squared x plus cosine squared x. So then I'm replacing one of those with a sine squared in the next one. Okay, and then this identity here is the most famous trig identity in the universe. That's 1 dx. So that's equal to integral 0 to pi over 2 of x dx, which is x, whoops, sorry, that's got a little too much notation there. I integrated that. So that's x evaluated from 0 to pi over 2, which is pi over 2, minus 0, which is pi over 2. Okay, so that's not, so what did I find? Let's just, hold on, time out, time out. Okay, what I found was that 2 times this is equal to pi over 2. So let's write it out. So 2, 0 to pi over 2 of cosine squared x dx is equal to pi over 2. So that means that the integral we were asked to find, cosine squared x dx, is equal to pi over 4, and that's also equal to the other integral that they wanted us to find, which was 0 to pi over 2 of sine squared x. Okay, there you go. That's the last one of this whole section. That feels good. Okay, thanks for watching.